Principal component analysis is a dimensionality reduction algorithm. We will now go through the steps of the PCA. X will be the toy dataset with 4 data points. First, we want it to have a 0 mean. We accomplish this by subtracting the mean from X. Next, we find the covariance matrix of the data. Then, we find the Eigen decomposition of the covariance matrix and normalize the eigenvectors to have a unit length. These eigenvectors are the principal components. They give us the directions of the variance. Larger the eigenvalue, larger the variance in that direction. The dimensionality of the data is reduced by projecting the data onto the lines corresponding with these directions. In this case, we will project the data onto the red line corresponding with V1 direction. Basically, we find the closest point on the line from each data point and remember the distance to travel in that direction. This is computed by taking the dot products between the chosen unit vector and the data points. What we get as a result is a one-dimensional array of distances in a certain direction. We can reconstruct the two-dimensional data from this one-dimensional result by going along the direction for calculated distances. We will lose some information about the original data, but that is because we compress the two-dimensional data into a one-dimensional array. We can preserve more information about the original data by using more principal components. Let us now use both principal components at once and see what happens. Here we have a reconstruction obtained earlier. Let us now project the data using a second principal component and reconstruct. If we now sum up these reconstructions, we will reconstruct the original data. Essentially what happens is that points go in the first direction for the calculated distances and then along the second. We saw that by using an eigenvector with the highest eigenvalue, we can preserve a lot of information about the data, but by using many principal components at once, it is possible to preserve even more information.